Hello everyone, welcome back. So today we have t to the power of 1 over 10 plus t to the power of 1 over 15 plus t to the power of 1 over 30 all equals to 84. So let's solve together. We're going to say solution. First, we're going to write the suitable equivalent for each of the powers as t to the power of 3 over 30. 3 over 30 is the same as 1 over 10 plus t to the power of 2 over 30, and 2 over 30 is equivalent to 1 over 15 plus t to the power of 1 over 30, and it's fine, all equal to 84. If you recall that a to the power of n or to the power of m is same as a to the power of m to the power of n also equals to a to the power of m times n. Here, if we keep this in mind, we're going to rewrite our equation as t to the power of 3 times 1 over 30 plus t to the power of 2 times 1 all over 30 plus t to the power of 1 over 30 all equal to 84. With this same exponential law in mind, we can also write as t to the power of 1 over 30 to the power of 3 plus t to the power of 1 over 30 to the power of 2 plus t to the power of 1 over 30 all equals to 84. So you can see that t to the power of 30 is common. So we can therefore say let t to the power of 1 over 30 be equals to k. That means that our equation therefore will become k to the power of 3 plus k to the power of 2 for this plus k all equal to 84. But don't forget this. Here we can write k to the power of 3 plus k to the power of 2 plus k minus 84 all equal to 0. So 84 comes to the left hand side, and the sign from positive will change to negative, and we're fine. So our next rule is to split 84 into three numbers in such a way that when these three numbers are carefully selected and written in an index form, they will produce a respective exponent of 1, 2, and 3 respectively. '84 is equals to, and this number can only be 64 plus 16 and plus 4, in a way that 64 can be written as 4 to the power of 3 plus 16 also can be written as 4 to the power of 2, and of course 4 is written to the power of 1, and it's fine. The next line will therefore become k to the power of 3 plus k to the power of 2 plus k to the power of 1 minus 64 minus 16 minus 4 all equal to 0. So the next line therefore will be k to the power of 3 plus k to the power of 2 plus k to the power of 1 minus here 4 to the power of 3 for 64 minus 4 to the power of 2, that is 16, minus 4 to the power of 1 all equal to 0, and we are fine. So here, the next thing, we're going to group them according to their powers. That is to say k to the power of 3 minus 4 to the power of 3 in bracket plus k to the power of 2 minus 4 to the power of 2 close the bracket plus k to the power of 1 minus 4 to the power of 1 all equal to 0, and it's good. Recall from algebra that a to the power 3 minus b to the power 3 is equivalent to a minus b times a squared plus ab plus b to the power of 2. This is in the form of this, where a is equal to k and b is equal to 4. So that the next line would therefore become k minus 4 for this into k squared plus 4k plus 4 to the power of 2, and this for this part, plus here k to the power of 2 minus 4 to the power of 2 plus k to the power of 1 minus 4 to the power of 1, all equal to 0. And again, from algebra, a to the power of 2 minus b to the power of 2, also equivalent to a plus b times a minus b. And this in the form of this, a is equal to k and b is equal to 4. So the next line will be k minus 4 times k squared plus 4k plus 4 to the power of 2 for this, close the bracket, plus for this we'll use this, that is k plus 4, k minus 4 plus k minus 4, all equal to 0. So we are going to factor out k minus 4, k minus 4, and k minus 4 from the three terms as k minus 4, close the bracket. This term divided by k minus 4 to be left with this, therefore k to the power of 2 plus 4k plus 4 to the power of 2, that is 16, plus this term divided by k minus 4 to be left with k plus 4 plus k minus 4 divided by k minus 4, that is 1, and close the bracket, all equal to 0. So we're going to simplify further as k minus 4 in a bracket, here k squared plus 4k plus 16 plus k plus 5. 4 plus 1 is equal to 5, all equal to 0. So k minus 4, k squared plus 4k plus k, that is 5k, plus 16 plus 5, that is 21, all equal to 0. K minus 4 into k squared plus 5k plus 21, all equal to 0. From this line, we end up having two cases that says either k minus 4 is equal to 0 or k squared plus 5k plus 21 is equal to 0. And from the first case, k is equals to 4. This is the first value of k. And from the second case, is a typical example of a quadratic equation. We want to check using the discriminant if the value of k will be real or complex number. And the discriminant says data is equals to b squared minus 4ac. And this is equals to b is 5 squared minus 4 times 1 times 21, and that is c. So if you solve this very well, we're going to end up having 25 as 5 squared minus 4 times 1 times 21, that is 84. And if you subtract this, 25 minus 84, that is minus 59. Obviously, this is far less than 0. So if you do this very well, this can only give us complex solution. So there's no real solution from here. That means it's rejected. So the only true value of k is k equals to 4. But recall that we accepted k to be equals to t to the power of 1 over 30. And now we have k to be equals to 4. Therefore, t to the power of 1 over 30 equals to k. And t to the power of 1 over 30 is equal to 4. If you multiply the power by 30, t will therefore be 1 over 30 times 30 equals to 4 to the power of 30. Here 30 cancels out 30 to be left with t equals to 4 to the power of 30, and this is the value of t. So if you want to know if the value of t as 4 to the power of 30 is true, we have to verify it using the original equation that says t to the power of 1 over 10 plus t to the power of 1 over 15 plus t to the power of 1 over 30 is equal to 84. So when we have t to be replaced with 4 to the power of 30, that is 4 to the power of 30 times 1 over 10 plus 4 to the power of 30 times 1 over 15 plus 4 to the power of 30 times 1 over 30, could this be equals to 84? So here 30 divided by 10, that is 3. So this point will be 4 to the power of 3 plus 30 divided by 15, and is 2, that's 4 to the power of 2 plus 30 divided by 30, that is 1 to the power of 1. Can this be equals to 84? 4 to the power of 3, that is 64, plus 4 to the power of 2, obviously that is 16, plus 4 to the power of 1 is 4. We want to know if this will be equals to 84. So if we add this up, 64 plus 16 plus 4 is 84. It's obviously 84. This shows that the value of t that we got as t equals to 4 to the power of 30 is actually true, because it satisfies the original equation as the right hand side is equal to the left hand side, and it's very fine. Thank you for staying tuned. Like, share and subscribe so that more persons can have access to this channel and benefit from the skills that we're displaying here. Thank you. God bless.